Hey there, boys and girls. Today we're going to take a look at a more accurate way to represent our remainders. So it turns out that we have three ways to represent our remainders when we're dividing. So the first way that we learned about, and you've been learning about since, maybe third grade, definitely fourth grade, and we've already taken a look at, is using the letter R for your remainder. So it turns out this is not a super accurate, or I should say precise way for us to express our remainders. Just simply tell people, hey, there's this much left over, isn't very useful. For instance, if you have $3 left over and you're splitting it up amongst 5 people or 4 people, that's not very helpful, because we can actually split those $3 up amongst those people. We can still split up $3 amongst 4 people or amongst 5 people. It just means each person gets less than $1, which is not a bad thing. It's still money. So we can represent it using decimals, and that's a prime example. Money, we deal with decimals. When you have less than $1, you're dealing with decimals. So we're going to learn how to tackle that. So our second way is we can represent it using decimals, and we can represent our remainders using fractions, which will be our next lesson. But let's focus on decimals for today. So to express our remainder as a decimal, we're going to go ahead and do what's called, we're going to annex, or simply we're just going to tack on, we're going to add a decimal and as many zeros as you need to continue dividing until you have a remainder of 0. Now, I forgot to add on here, but I would love it if you could please add this onto your notes. When you have your decimal in your dividend, you're going to bring your decimal straight up into your quotient, into your answer. Now that's super important. Sorry. You need to bring your decimal straight on up to your quotient. I call it taking the elevator ride. Your decimal is going to go straight up into your quotient. So let's do an example. So we have 457 divided by 2. The first thing I'm going to do is go ahead and set this up. So we have 457 divided by 2. And I'm going to start chipping away and see what happens. So 2 goes into 4. 2 times. 2 times 2 is 4. I subtract. I bring down the 5. 2 goes into 5 twice. I subtract 4. I have 1. I bring down the 7. 2 goes into 17 8 times. I subtract 16. I'm left with 1. Now, we used to just say remainder 1. But again, if this was money and you had $1 left, but you're splitting it up amongst 2 people, it doesn't mean that that's impossible. We can totally do that. We can go ahead and take $1 and split it up amongst 2 people. Each person gets 50 cents. Now let's see with our math how we end up getting 50 cents. So I'm going to go ahead and add a decimal and a 0. I'm just going to tack it on because this is still exactly the same number. This is still just 457. I have not changed the problem at all. So now I'm going to bring down that 0, and now my number's 10. 2 goes into 10 5 times. 2 times 5 is 10. I subtract. My remainder is 0, so I'm done dividing. But my last step is that I need to bring my decimal straight up into my quotient. So if we take a look here, and you might be wondering, well, Ms. Gannon, you just said that each person, since we had the remainder of 1 and we were splitting it up amongst 2 people, that everybody would get 50 cents. Well, yeah, they would. I can go ahead and tack on another 0 if I want. Boom. $228.50. Now this is why I love this method, because it's much more precise. To actually split up that dollar amongst the 2 people and give them 50 cents each, you have done that math thoroughly. You're completely done. Whereas if you just say, hey, there's $1 left over, well, tell me, what can we do with that extra $1? All right, let's do another example together. 297 divided by 4. Okay, I'm going to start my largest place value. 4 does not go into 1. I'm going to use my 0 placeholder because, again, we need to make sure all these numbers stay lined up so that if I bring my decimal up, it's in the right spot. 4 goes into 12 3 times. I subtract 12. I bring down the 9. 4 goes into 9 twice. I subtract 8. 4 goes into 17 4 times. I subtract 16. I have 1 left over. Now again, some people might say, hey, you got 1 left over. Well, if you have $1, isn't it true that you can still split it up amongst 4 people? Absolutely. You absolutely can. So let's go ahead and see how much money they would end up getting. So let's add a decimal and a 0. Now let's bring that 0 down. So this is now 10. 4 goes into 10. Let me extend this out twice. I subtract 8. I have 2. I'm going to add yet another 0 because my remainder is not 0 yet. So I'm going to add a 0, bring it on down. 4 goes into 20 5 times. 4 times 5 is 20. I subtract. My remainder is 0. So I'm almost done. I'm going to go ahead and bring my decimal straight on up. And what that means is that everybody would get $324.25. And again, that's because we had this remainder of $1 split up amongst 4 people is 25 cents. It all ties together. It all makes sense. So let's do 2 more examples together. And then please practice on your own on the back side with the practice problems. All right, 324 divided by 5. 5 does not go into 3, so I'm going to use my 0 placeholder. 5 does go into 32. 5 goes into 32, let's see, 6 times. I subtract 30. Got 2 left over. Bring down the 4. 5 goes into 24 4 times. I subtract 20. I have 4 left over. Again, $4. If we're splitting it up amongst 5 people, we can do that. We're going to get something less than 1, and that's exactly what decimals represent, values less than 1. So let's go ahead, tack on a 0 and bring it on down. And do not forget that decimal, because if you do, you've changed your number. If you don't have that decimal, you're saying that it's 3,240, which is totally false. We can't change the number. We need to keep it 324. If you add your decimal and your 0, you're still at 324, so you're good to go. Let's bring our decimal straight up, and 5 goes into 40 8 times. So our answer would be 64 8/10. And the last one, 825 divided by 4. 4 goes into 8 twice. 4 goes into 2 0 times. I could subtract 0. I'm still at 2. I bring down the 5. 4 goes into 25. Let's see, 6 times minus 24. 1 left over. Again, I'm not going to just stop there. I'm going to go ahead and tack on some zeros. Bring it on down. 4 goes into 10 twice. Minus 8 is 2. 4 goes into 25 times. My remainder is 0. So once I've brought my decimal straight up, I am done. So that's 206 and 25 hundredths, to say that precisely.